Welcome to section 2.3, Techniques for Computing Limits. These techniques are actually pretty easy. The only thing you're going to be worried about is if you run into a situation where you have to do something, maybe algebraically manipulate the limit or something like that. So what I'd like to begin with are just the limit laws. So let me go ahead and let me copy and paste them. Now these can be found page 72 in your book, all right? And these are just our limit laws for limits itself. So you can add two functions together, or I'm sorry, if you're adding two functions together and there's a limit outside, you can distribute the limit. Same thing with the difference. The constant multiple, one of my favorites, you can actually take the constant, which is out front of the function, and move it in front of the limit. It doesn't change anything. You can, if you're multiplying two functions together, the product of them would just be the limits of each individual function multiplied. Same thing with the quotient, the power of a limit, root of a limit, so forth. Now, the easiest way to compute a limit algebraically is to just substitute in whatever the value is. So I think a really good example here would be something along the lines of, let me just write example. Let me use a white marker here. Sorry, should have had this prepared. So find the limit for the following examples. So the first one, it's going to be very simple. The limit as x approaches 2 of x squared plus 4. Now, anytime you approach this, like I said, the first thing you want to try to do is just take the value of the limit and substitute it in. See what you get. So in this case, we get 2 squared plus 4. We know 2 squared is 4. And 4 plus 4 equals 8. So the limit as x approaches 2 of x squared plus 4 equals 8. It's that easy, okay? Another thing that you want to look at here would be an example like this, okay? Let's say we wanted the limit as x approaches 2 of the square root 2x cubed plus 9 plus 2x minus 7 all over 2x plus 5. Once again, substitute in the limit first, see what happens, okay? So wherever we see an x, we're going to go ahead, square root's too big. We're going to go ahead and just make our substitution. Now, I don't know, I'm very old school. I like to write parentheses wherever I see my variable first. And then I make my substitutions. And the reason for that is only because I don't want to miss like a double negative or anything back to back. So I'm going to substitute into 2. And all I have to do from here is just literally crunch the numbers. So let's see here. 2 to the third is, is 8. 8 times 2 is 16. Plus 4 minus 7 all over 4 plus 5. 16 plus 9, square root of 25. Plus 4 minus 7 all over 9. So we get 5 plus 4. This goes to 5. So 5 plus 4 is 9. Minus 7 is 2 over 9 for a limit. Okay? Now, we can even take this one step further. Okay? And we can calculate one-sided limits if we wanted to. Now, one-sided limits, if it's a function, so let me just show you an example here. So let's say we wanted to find the limit as x approaches -1 from the right of 3x to the third plus 1. Okay? Now, personally, what I would do, because we're learning this, is you need to think about a number line. Here's -1, and since we're approaching from the right, we want values of x that are on the right-hand side of -1. Also, they need to be very, very close to -1. The closer you get to -1, the better the approximation for your limit is actually going to be. So what I'm going to do is I'm going to choose a value, like I said, to the right of -1. And let's just call it negative 0.99. Okay? Now, the easiest thing to do here is just get out a calculator. So let me get out my calculator here. As you can see here, Destiny 2 background. I'm a huge video game player. I like video games a lot. So if you need to know how to install this is it's an emulator. It's a free version of a calculator. Let me know, email me, and I can show you how to do that. So what was the function again? 2, was it 2? 3, okay. So it's 3 parenthesis negative 0.99 to the third power. And then I forget, was it +1 or -1? +1, perfect. So this looks like it's negative 1.91. So it's approximately negative 1.91. Depending upon what the directions say, make sure you read the directions. If it says round to the nearest whole number, I'm going to call it -2. Okay? So that's how you calculate a one-sided limit. But then we also have other types of one-sided limits. For example, let's say f of x equals a piecewise defined function. So the piecewise defined function, the first piece, negative 2x plus 4, if x is less than 1, or the square root of x minus 1 if x is greater than 1. So the first piece, negative 2x plus 4, if x is less than or equal to 1. And then the square root of x minus 1 if x is greater than 1. Now, if you forget how to draw a piecewise defined function, I'm going to show you right now. The best thing for you to do is to, honestly, put down your pen or a pencil and just watch. All right? Because I do it it's not a specific way, but it's actually, for me, it's the easiest way. So I'm going to just go ahead, do my little XY, Cartesian coordinate plane. And what I'm going to do is I'm going to assume for a second that the first piece is just a complete line. I'm not going to worry about the restrictions on my x values. So I have a linear equation here. 0, 4 is my y-intercept. And then I use my slope to determine my next point. So I start at the y-intercept. I'm going to go down 2 units and to the right 1 unit. Okay? And I'm going to pretend just to draw a line right here. So just like I said, be careful. I don't write this down yet because I'm going to be doing something here in a second. So if I were to draw this line, that's what it would look like. Okay? However, now my brain turns back on and I'm like, oh, wait a minute. I do have a restriction. I want values of x that are less than or equal to 1. So I go to my x value 1, which is right here. I come up here. I make sure this is a solid dot. And I'm going to erase the side of my function where the x values get larger and larger and larger. So right here is going to be my first part of my piecewise defined function. Now, the second part, I'm just going to assume for the time being that it is just y equals the square root of x minus 1. So my parent function is going to be the square root. Since it's since my translation is inside of the function, inside of the parent function, I'm going to move to the right 1 unit. So move 1 unit and just kind of draw what it looks like, just like that. However, my brain needs to turn back on. I need to look at my restriction, and I want values of x that are greater than 1. So I go to 1, and instead of it being a solid dot, in fact, let's make this pretty. I'm just going to write a big open dot. And right there is my piecewise defined function. That's the easiest way for me to do this. Normally, I use a pencil and just lightly draw the lines and then erase what I don't need. Okay? So now that we have our piecewise defined function here, let's go ahead and let's evaluate the limit as x approaches 1 from the left of f of x. Well, remember, we're approaching from the left, so we're coming this way. I pretend I'm walking on a line, and I look up, and since I'm approaching 1 from the left, we're coming down this way, and that looks like it's going to equal 2. Now, another way you can actually do this is to actually choose a value, or better yet, just substitute in the 1, because you're allowed to equal 1 here. So you can take the first piece, and just substitute in the value. Negative 2 times 1 plus 4 equals 2. And that's the same thing we got there. So visually, it makes sense. Algebraically, it also makes sense. Okay? Now, let's look at the other side here. Let's try to find the limit as x approaches 1 from the right. Sorry if you can hear my dog in the background. My wife and I just got a puppy a couple months ago, and now he gets the zoomies. So if you hear him barking in the back, I'm sorry. But we're going to approach the limit as x approaches 1 from the right of f of x. Now, once again, I pretend that I'm walking on the x-axis, and I'm coming this way, and it looks like it's going to be 0, okay? You can also do it the same way. So let me write it out again. Let's just substitute in our value. 1 minus 1 equals the square root of 0. So that equals 0 as well. So visually it makes sense. Algebraically it makes sense. Now, the last limit I want to calculate here, and this is going to be the easiest. What is the limit as x approaches 1 of f of x? Well, no matter what, remember, the left side of the limit has to equal the right side of the limit. If it does, whatever those values are, that's going to be the limit as you approach 1. In this case, 2 does not equal 0. So we say the limit as x approaches 1 of my piecewise defined function does not exist. Okay? Now, there are some other techniques that we do have to be concerned with. Okay? I think a really good example here, it's going to look like something like this. Let's find a limit as x approaches 2 of x squared plus 6x plus 8. Let's make it minus 6. All over x squared minus 4. So if we were to just approach this the same way that we've been approaching every other limit example here, we would take whatever the limit is, substitute in for x. I'm not even going to worry about the numerator because I know when I substitute in 2 for x, I get 2 squared minus 4, which means we get a 0 in the denominator. Now, do not assume that because you got a 0 in a denominator that this is undefined and there is no limit. That's not the case. So sometimes you got to be clever. When you come across a situation like this where the limit ends up breaking in some manner, you need to think about, okay, well, is there anything I can do to the function itself where I can simplify? So this is where all your algebraic techniques kick in. So the limit as x approaches 2. Let's keep this simple. In the denominator, I have difference of squares. I know that factors down into x plus 2, x minus 2. In the numerator, I have a trinomial with the leading coefficient equal to 1. So that's going to be the multiplication of 2 binomials. I write an x and an x. I always do my signs first. I know they're both going to be negative because I know that 8 is positive, which means the last two things I multiply have to equal a positive number. I don't care what the number is. I know it's positive. So my signs are both negative. Now all I need are just two numbers that multiply to get 8, but also combine to give me 6, and that's going to be 2 and 4. Let me write the 4 first. You'll see why in a second. So x minus 4, x minus 2. Now note that I can reduce the x minus 2's. That's going to give me the limit as x approaches 2 of x minus 4 over x plus 2. Now I'm going to go ahead and try it again. I'm going to make my substitution. I get 2 minus 4 over 2 plus 2. In the numerator, I get negative 2. In the denominator, I get 4. That reduces down into negative 1/2. So you got to be really careful when you start evaluating limits, because initially it may seem like there is no limit, but in reality, there actually is a limit. And in this case, the limit as x approaches 2 of x squared minus 6x plus 8 all over x squared minus 4 equals negative 1/2.